here is a solution to the rotation problem that I assigned for my AP Physics students this week. We're told that a 1 meter diameter solid disk, I'm going to make a sketch of this. The radius of this disk, r, is equal to 1 meter. And we're told that the mass of this disk is 10 kilograms. And it's spinning around, and the time it takes to spin around, we're told, is once per second. So the time of orbit is 1 second. And then we're asked what is the angular momentum of the disk and what constant torque must be applied to bring it to rest in 5 seconds. So the first part, we need to know the angular momentum of the disk. Well, you might remember the angular momentum is equal to the rotational inertia times its angular velocity. This is for rotation of a rigid or solid body, solid object. So we are told that its rotation rate is once per second, so we know that its angular velocity is going to be 2 pi times the frequency of rotation, which is 2 pi over the period, which is just going to be 2 pi radians per second, because it takes 1 second to get around. So that's the angular velocity. Well, what's its rotational inertia? Well, a disk, well, more generally speaking, beta mr squared is the rotational inertia of a solid object. For a disk, beta is equal to 1/2. So 1/2 times its mass, which would be 10 kilograms, times the radius, which would be 1 meter squared. So it has a rotational inertia I equal to 5 kilograms meters squared. And so we can plug these in to find out that its angular momentum when it starts is going to be 5 kilograms meters squared times 2 pi radians per second. And so we have 10 kilograms meters squared per second are the units of the angular momentum. Then we're asked to find the torque that needs to be applied to it in order to bring it to a rest in 5 seconds. Well, I'm going to just kind of show what's going on here. It's got some angular velocity, some initial angular velocity, maybe I'll call that its initial angular velocity, of 2 pi, and it comes to a complete stop in a time of 5 seconds. So we need to know how quickly it's losing its angular velocity. Well, that would be its angular acceleration, or in this case, deceleration. It's its change in angular velocity during a particular time interval. Well, its change has to lose all 2 pi radians per second of its angular velocity, and the time it's going to take is 5 seconds. And so the angular acceleration is going to be 2 pi over 5 radians per second squared. Well, now we need to know what the torque that must be applied to it. You might recall that torque is equal to I times alpha. This is kind of like when we have force equals mass times acceleration. This is the angular form of Newton's second law. And so we can just plug in the rotational inertia, which would be 5 kilograms meters squared, and alpha is 2 pi over 5 radians per second squared. The 5's cancel, and lo and behold, we get a torque of 2 pi, and the units for that would be in kilograms meters squared per second squared. So that would be the torque that is required.